I want to welcome everybody who took time on this beautiful, wet evening in Minnesota to check out this. This is, to me, just an awesome presentation that Brian's got put together. And Brian has been working for this company for a number of years. He's, how do you pronounce your last name, Brian?
Urlaub.
Urlaub, okay. He's director of geothermal operations for the company, and he's been involved in all aspects over the years. And so I'm really, really thankful that he took the time to be with us tonight. I got lots of good reviews on other presentation he's done, so that was a kick in the right direction for me. So anyway, Brian, please go ahead and start your presentation.
Great, thanks, Doug. I really appreciate it. Thanks for having me. Yeah, my name's Brian Urlaub. I work for Salas O'Brien, as you can see here on the screen, and I'm going to just talk a little bit about our company, what we do, specifically related to our decarbonization and geothermal experience. Talk a little bit about my history and again specifically related to geothermal. That's what I've been focused on most of my career. And then I'm going to show you a little example project at the end that just kind of show you a little bit about when you couple solar, photovoltaic solar energy and geothermal and energy efficiency together, what can be accomplished. So we'll just kind of go through this. Again, I've been in the industry for a long time, just 51 years young, and I went actually through tech school back in 1991 to 93. I started out going through a 2-year associate's program at CVTC over in Eau Claire for HVAC design. And then I went off and like most people out of the trade schools, started out in the field, started to get my hands dirty as an installer, as a service technician, working on residential, light commercial refrigeration, heating and cooling systems. And in 1998, back then it was Northern States Power, it wasn't Xcel Energy any longer, or prior to that, Xcel Energy merger there. They had done a installer's course from the International Ground Source Heat Pump Association on geothermal technology. And I was working for a company, a heating contractor out in Maple Plain. And I went through that program and I got really excited about it. I thought, man, this is really neat. You can actually take heat from the ground and heat somebody's home and save them a bunch of money on their utilities, and it lasts longer. And there's all these benefits. And I thought, wow, this is exciting. And so I went back and we put in a couple of systems, got some more training, and really, like I said, just found passion in the technology. And in 2001, I moved on to working for a geothermal heat pump manufacturer. They started out as a distributor, then they moved into manufacturing. They were out of Illinois. I was initially started out doing sales and dealer support. And so I was traveling around. My territory was the state of Minnesota. So I was traveling around Minnesota, helping heating contractors learn about geothermal heat pumps, training them how to install them, how to service them, how to size them, how to design them. And, I've worked for that company for 16 years. And, over the 16 years, of course, kind of grew with the company, moved more into management and help in engineering, actually design products and marketing team design, marketing campaigns. And so just did a lot of things, but all specifically related to the geothermal heat pump industry. And for those majority of those years, those early years, before the first tax credit, geothermal heat pumps were less than 2% of the HVAC market nationwide. Very small, kind of a niche market. Minnesota actually back then was one of the better states that did a lot of residential heat pumps, primarily because there was a heat pump manufacturer located right in the state of Minnesota. There was a company called Econar. I don't know if you remember that. They were located in Elk River. They had a lot of support from rural electric cooperatives and Great River Energy. And so they had a lot of dealers, and they had been installing and manufacturing geothermal heat pumps since the late 80s, early 90s. And so, Minnesota was a great place for geothermal heat pumps. The electric cooperatives were very excited about the technology. They had great incentives. They talked to their, members about the technology and had a dealer network. And so there were a lot of residential and light commercial systems going on. And, there were even some commercial. There were a lot of K through 12 schools that had went geothermal heat pumps, primarily because of Econ-R and their local presence. And so, I was working around the state, and then I kind of expanded out throughout the country, working with Intertech. And meanwhile, my brother, my older brother, started an engineering firm 22 years ago over in Eau Claire, Wisconsin, called MEP Associates. And after he had that firm going a couple of years, I brought him a couple of commercial projects to design around geothermal. And so I kind of got him into the geothermal heat pump industry. He'll blame me for that. And anyway, so he became one of the premier engineers around the Midwest for designing geothermal heat pump systems for commercial buildings. And now he's very well known nationally for doing a lot of large university and campus conversions from, and I'll show you, actually, I don't know if I have a slide here, but so he was the engineer that designed Ball State, if you've ever heard of Ball State, but Ball State was the first university campus to convert their whole campus from a legacy steam and coal-fired system to a geothermal heat pump system. And it took about a decade, but my brother engineered that system, and that was kind of the catalyst for the whole campus and higher education world to start looking at doing that. And now we're working at between 20 and 30 universities across the country, depending on, what time of year it is, and if we've, ending a project or starting a new project. But and I will show you a map about a lot of those that we've actually been working with. So I moved over to work with my brother about 5.5 years ago. And since then, I've been the director of geothermal operations with MEP. And then he merged with Salas O'Brien 3 years ago. So I've been with the company almost, like I said, 5.5 years, with Salas O'Brien 3.5, because I started out first at MEP and then he merged. So a little bit about my background as well within the industry. I'm currently sitting on the board of directors with the International Ground Source Heat Pump Association. I've been very involved in that organization. That's our national organization that supports the industry with training, with technical information, manuals, case studies, a lot of standards and codes. So I've been involved in that organization since the late 90s, when I, first went through my first course. I immediately, after starting with Intertech, went down, became a trainer, was involved in their advisory council, helped that organization over the years, just kind of become what it is today. And then also the Minnesota Geothermal Heat Pump Association. I was board of directors on that a number of years ago, was one of the board members that first kind of resurrected it. There was an association for a long period of time in the 90s, and then it died. They ran out of funding. They didn't have anybody running it. And then in the late, I guess it was probably around 2010 or so, that organization was resurrected. I was one of the first board members on the new board in the new organization that kind of came back to life, and they're still there, and they're small, but they're trying. Really great people there that run that, and a lot of good information there as well, if you ever get a chance to see the website. So a little bit about Salas O'Brien. We're an employee-owned firm, and the majority of our team members, our professional team members, are really focused on the built environment and delivering high-quality, innovative solutions to our clients. So when I first merged with my brother into the company, there was about 600 employees, and I'll kind of show you the timeline here in a minute. Today, we are now over 4,000 employees across North America, including Canada. So we're on a really big acquisition and growth phase. We're merging with a lot of different companies across the country, and we're merging with companies across all different market segments and in disciplines. We're actually getting more involved in telecommunications, in food and beverage, process engineering. We also have a large civil and structural group. So we're trying to offer everything we can across, the discipline and market segment within the built environment. And then again, also with the food and beverage processing. So that's a little bit about, our firm. I'll kind of give you a little more here. So, Doug kind of asked, what's your mission as a company? And really, this kind of sums it up. It's sustainable from beginning, built to last. And that's really our mission statement. We're really, our passion is about the people that work here, and then our clients, and, the people that work here, the opportunity for growth, to help them in their careers, to, help them learn and really look at innovation and then drive that innovation through our clients and help our clients have very successful projects, not only from, just not having issues as you go through construction and so forth, but it's really about delivering systems that are reliable, that last a long time, that have low maintenance, that are sustainable, that have, and that's including all the way from embedded carbon all the way through, the life of the product. So we're constantly looking at, how can we be better? And that's really our foundation. And that really comes, through our leaders, and I'll show you who those are here in just a minute. But again, I've mentioned all the things that we do. You can kind of see here. I'm not going to go through all this, but we really do a lot of different things. We, with obviously 4,000 or so professionals, we get into a lot of different types of systems. Energy and resiliency is a big one. Obviously, the decarbonization and electrification movement across the country is really driving a lot of that. You have LEED and WELL, as kind of standards, if you will, that drive a lot of innovation as well within the built environment. That we have teams that work through those processes, and so again, we do a lot of different things, but primarily around the built environment. And again, all the different market segments. We're really big into healthcare. We do a lot of hospital work. One of our biggest clients is obviously Mayo Clinic in Rochester, and also around the country. We work with them in all their satellite locations. Also, if you've ever heard of Epic, they're the large healthcare data software company down in Verona, Wisconsin. We've been working on their campus almost since the beginning, and that campus is 100% carbon free, on site, a lot of electric generation, 100% geothermal, really impressive site. So we do a lot of healthcare, we do a lot of education, mainly higher education, but we also, in certain markets like Texas and Oklahoma, do a lot of K through 12. Would love to do more here in Minnesota. We've got a great K through 12 school team that really knows that, market and the design those systems really well. We also got a great high-rise team down in the Chicago market that does a lot of high-rise work. We do a lot of mixed use and multifamily around the country, primarily in New York and Toronto. We do a tremendous amount of those types of buildings. Again, science and technology. We worked at the U of M. When they did their big new athletic center, we were the design engineer on that project. So we get involved with some federal work, military, across the board. We do a lot of different things. And in all those segments, we're always trying to look at sustainability, energy efficiency, decarbonization, just trying to really push the envelopes with technology and make sure that our clients are getting, something that's going to be the next, legacy system for however long that building is standing. Again, this is a little bit about Salas O'Brien and just our history. Started out in 1975, was founded by Dan O'Brien. And as you can see, kind of grew over the years. In 2008, we made our first MEP Giants list at number 97. And that kind of really at that point started to put them into the acquisition mode. And as you can see, they started to join with other firms like KDW, Coleman's, Marshall in 2014. And then, again, WMA in 2019, MEP Associates in 2019-20, Global Engineering Solutions, KPW. And so now we're at 2024. And again, 600 employees roughly in 2020 and 4,000 today. So 70 or 80 plus offices around the country, something like that. So just tremendous growth. but it's very interesting how the company is structured. So all the principals stay on for a minimum of 5 years. They help maintain the culture. They help maintain the client base. The clients make sure that, you know, the teams are still intact and everybody that's still working, they're used to working on their projects are here. And then we just slowly try to integrate standards across the, you know, the company. You know, and then of course there's a lot of internal stuff, you know, that you have to integrate, but from an outward facing integration, it's really worked well. And we do not have a lot of turnover, and most of our principals all stay, you know, past the 5 years. These are some of our leaders within the organization. Darren Anderson is our chairman and CEO. Paul Silva is the president and COO. Deidre McDaniel, she's the president, if you will, of CMT Ops, which is our central group. That's who I report to. So she runs kind of our central business unit, and our central business unit is the largest unit in the decarbonization and sustainable world. So all the campus energy work that we do is all in our business unit that reports to Deidre. And that goes across the country. So we have offices in Denver and in Hartford, Connecticut that all kind of work within that same business unit. We have federal business unit. We have telecommunications out west. We, you know, in California, we have a large solar group that does a lot of solar farm work, microgrid work, a lot of on the electrical, you know, grid side of things. So we've got a lot of different, you know, principals, and they manage a lot of different groups. And then of course, it's just nice to be able to have that bench and be able to share and find teams that if you get into a project and you need somebody that does acoustical design, or you need somebody that does structural, you know, we have it within our organization, and we collaborate, and it works very well. So just wanted to touch base again back to the decarbonization work that we do, and this is primarily almost all within our business unit, but this is a map just of the higher education and campus, private and public campus projects that we get involved with or have been involved with, whether it's through master planning or through planning and through construction. So you can see like EPIC here in Wisconsin, which is the largest geothermal system in North America, if not the world. I don't know for that for sure, but we know in North America. You know, right here in Minnesota, you have Carleton College, you have the U of M. In Iowa, you have Luther and Grinnell that are converting their campuses and decarbonizing. You can clearly see in Massachusetts, there's a lot of colleges that we're working at, Amherst and Smith and Mount Holyoke and Wellesley, Dartmouth. Those are all college campuses that we're deep into design of converting their systems from fossil fuel and steam to low temperature, all electric heat pump systems, multi-technology systems, whether it's geothermal, air source, thermal energy storage, and go, you know, fully decarbonized on-site central energy plants. And so most of those are very deep into the design, and some of them are in phasing of the construction. We'll be at most of these places for at least a decade or so. Princeton just started up their first large new central energy plant that's producing 2/3 of the energy for their campus, all off of geothermal and thermal energy storage. So you can see that this is a major part of our business, and specifically our business unit. And it's something that we're very well known for. And like I mentioned before, it all started with Ball State University when my brother did that, you know, almost 20 years ago, 18 years ago, started that project. So these are some of the local projects that we've done and that my brother and his firm had done over the last 22 years. And some of them we're working on today. So Como Zoo is a current active project. We're converting the primate building and the polar bear building to a geothermal heat pump system. So they're currently on a fossil fuel steam system. The steam system is starting to fail. The piping underground is failing. And so they wanted to decentralize, move to a, you know, a zero carbon on-site type application, which is geothermal. And so that's what we're doing there. So that's really an exciting project. They actually had a federal grant for the primate building, which kicked that kind of project into high gear. And our client that's running that is Honeywell. So they're doing like a performance contract with the city. Hormel Foods in Austin, Carleton College, as I mentioned, they're about half their campus has been converted to geothermal off of the fossil fuel system. They're still in process of converting that additional buildings onto the system. Again, hospitals, Mayo Clinic, Big Fork Valley Hospital, the city of Rochester is doing a complete renovation and design of the downtown district and trying to go to a low temperature geothermal system and put buildings on, and they're really trying to set a standard for what a city would look like from a decarbonized district energy perspective. A lot of justice centers. You look at Mankato and Faribault. The U of M bee discovery out at the Arboretum was a really interesting project that actually won some awards. It was architecturally really an interesting project. It's a learning center. It's talking about bees. And so they have kids coming in all the time doing field trips just to learn about how bees are so important to our environment. And so that's 100% geothermal, heated and cooled. It's got radiant cooling and radiant heating, so it's super comfortable. You don't see any of the components. There's no ductwork really other than a little bit for ventilation. And the kids are sitting on the concrete floor and you think, geez, that's uncomfortable, but it's nice and warm in the winter. It's a little cool in the summer. And so that's a really interesting project. So if you ever get out there, take a little trip over to the bee discovery and go look at it. It's really, really interesting. So you can see we've done a lot. The Walk on TP is a current project that just started. And Dakota Community College in down by Apple Valley is also another geothermal project. So we've done a lot of geothermal in the state over the years. Those are the ones that I could pull from a quick project sheet that we had. I know there's more than that. There's a dental clinic I know in Apple Valley, Dulcet Dental. There's a a church right next door that's also geothermal. So yeah, there's Lifetime Fitness in Apple Valley. That's geothermal. The Apple Valley liquor store is geothermal. So that we were involved with. So there's a tremendous amount of projects in the state of Minnesota, and then residentially, of course, there's thousands of homes heated and cooled with geothermal across the state, all the way from Baudette and International Falls, all the way to to the Iowa border and everywhere in between. So the systems work great. They're in the city, middle of St. Paul and Minneapolis. There's systems, and so it's not just rural areas. It's everywhere. Let's talk a little bit about the recent news and what's happening in the industry related to regulation and primarily on the federal level. We'll talk a little bit about the state level, but the biggest change in the industry back in 2005, when the initial tax credit came out, there was a 30% tax credit for residential, but there was really nothing for commercial. It was, I think, 6% for commercial. They had an accelerated depreciation, but it really didn't move the needle for commercial projects. Especially back then, all the way through the late 2000s and then into the, 2010 to 2020, even, natural gas has been at historic lows for over a decade. We did have the 1 or 2 years in there where propane and everything kind of spiked. It drew a lot of attention. All of a sudden we saw a big boost in geothermal sales. The tax credit was there. People were taking advantage, especially on the residential side. But developers and building owners in the commercial sector just still didn't see the payback, because when they look at financials, they're looking at something less than 10 years for a decent return. If it's not, they're just really not interested. Residentially, if you're going to build a new house or invest in a system in your home, you're looking at longer term. So it's a little different mindset when it's your home versus a business. So, residentially, it was really good. Well, with the Inflation Reduction Act, they're actually now really boosted the commercial tax credits in a number of ways. There's a lot of stipulations with that tax credit, of course, but the tax credit amount is massive. When you look at the size of these projects that are happening today, especially at the universities, because now the biggest thing that they did was they changed it from you don't have to be a tax paying entity. Now there's a direct payment for tax-paying entities, nonprofits, universities, state, organizations, federal organizations can take the tax credit as a direct payment. And so that changed the game, number one, for those organizations. So all these universities that we're working at are all looking at this going, oh, geez, I'm spending $60 million on a new system and I'm going to get 30% paid for with a direct pay. So that's changed the game. Also, even from the residential developers in New York City that do affordable housing are now putting in geothermal heat pumps in new buildings that you'd never saw before. And it's 100% related to the tax credits and local law 97 in New York City specifically, but around the country, Colorado, Massachusetts, they're doing it. And it's really related to looking at futures with natural gas prices. As more people, go away from that, less people have to bear the burden of the gas costs and all the infrastructure costs, because that's going to get passed on as stranded assets become a real thing. Local, there's more carbon taxes happening. That's happening in Toronto. It's happening in Boston. It's happening in New York City. It's happening in California. So as those things start to also happen, other technologies are becoming, more attractive, because, there's either the carrot or the stick, and one way or the other, you're getting incentivized to do something different, whether it's the carrot or the stick. So, and both of them are happening, just depends on, where you're located. But so now you're eligible as much as 50% on geothermal. There's a lot of stipulations for the ITC. So it goes from 66% to 30% if you're using union or organized labor and apprenticeship programs. And then from 30% to 40% if it's in a disadvantaged community, and then 40% to 50%, there's two 10% bonuses, one for the disadvantaged community, the other one is for domestic content. That one is really tricky. That one has been very, very difficult to get clear direction from the Treasury, but those are available. So there's some risk to the tax credits, of course. It isn't just here's 30% of our project cost, we'll take the money. But that's really moved the needle in all market segments, across the country. We're seeing geothermal and commercial where we haven't seen it before. So do we want to take questions now, or do we want to take them at the end? I see John's got his hand raised, so I don't know, John, you want to ask a question?
Can you hear me?
Yes.
I have a question. I'm working with a couple groups in Minneapolis that are pushing hard on the city council and the mayor to increase funding for citywide network geothermal.
Yes.
I don't know if I just want to know if you're conversant with that idea, and there's a pilot project starting in part of Minneapolis. I just want to know if you're connected to that at all.
I'm not actually connected to the Minneapolis City Council. I have been a little bit connected to the state that passed a law recently that now opened up the door for regulated utilities to offer these thermal networks as part of their services. And so both XL Energy and Centerpoint Energy are working on RFPs to work on a couple of pilot projects here in the state and to start looking at that. Now, obviously, any additional funding to drive that pilot project in your district or in your city, I'm sure would be welcomed. There was a DOE grant that had been awarded for design, and 11 projects were awarded. Within that first grant for design, our company happens to be on 2 of those teams. We're in design right now. There'll be a down select later this fall. 3 or 4 of those projects of the 11 will get chosen to move to construction. None of those, one of those happens to be in Duluth with the wastewater treatment system and their district energy up there. So this thermal energy network concept is becoming probably the biggest hype I've ever seen in the geothermal industry in 25 years. It's the biggest buzzword. It's everywhere. Every municipality, every state seems to be talking about this. Eversource in Massachusetts just started their system. They've been getting a ton of press. I do believe that it's the future. I've been talking about this for 15 years that utilities need to be the ones owning infrastructure and take the burden off the homeowner. It's happening. I hope it happens faster because we have a lot of lofty goals to decarbonize our built environment in this country. And so this is a way to hopefully get more mass adoption quicker, because if you have to go door to door, it's going to take forever. So we need large companies like utilities to be able to go out and be able to amortize the cost through rate cases for 80 years or whatever that is. So people don't see massive increase in their home utilities. And so I think these pilot projects are going to be great. I'd love to see one in Minneapolis. I know there's one in St. Paul that's going to be happening, but it's not one of the pilot projects. It's just a new thermal network at the Hillcrest site with the St. Paul District Energy Company. So
if I could interject, Brian,
sure.
we are in conversation with the Massachusetts people.
Great.
And with the St. Paul group. We were a very direct influence on the city putting in the $10 million money that they're raising for the Minneapolis Climate Action Plan, which is going to start mostly with just better insulating people's homes. But
yeah,
we're proposing very directly and in conversation with them about raising $100 million over 10 years to start massively doing the network geothermal throughout the city, starting in the most underserved neighborhoods.
Yep.
So most of it's residential, but it's commercial too. I just wanted you to know.
Yeah, no, that's great and great work. I mean, absolutely. I'm excited for those projects. I think that is, and we're working on probably 4 or 5 of them right now. We were the first engineering firm to design one, build one, and put it in operation up in Markham, Ontario. It's been in operation for 2 years, 312 homes, all interconnected on one thermal energy network. 144 boreholes. Everything is utility grade, located in the street. Nothing is in anybody's yards. No, nothing is above grade. It's all below ground and vaults. It's a very interesting project. So we've been working on these for quite some time. We feel that we're the leader kind of in this space, and we're working with Eversource on the second phase of their project. We're working on 2 of the DOE projects. We've got a number of other ones in the works right now that we're designing. I was very surprised that Evergreen didn't come to us and talk to us about Hillcrest, because we're working with them on another project. So I'm not really sure why we didn't even get an opportunity there. But anyway, so we're really trying to ramp up, and I'm hoping that we can, win the projects when the RFPs come out with Excel and Centerpoint, because I think that we certainly have the expertise. It's just, there's always a lot of other things that happen with, with those RFPs and why people get selected. So, but hopefully we'll have a good shot at it and can win those and be working right here, in Minnesota doing these projects. So, and then we're also really excited about I believe the governor is going to sign the bill. There was a bill that went through. I don't know what else is attached to it, but it had to do with opening the regulation on open loop reinjection systems in the state. This was kind of a coalition of people that went together. Mayo Clinic was one of the large groups and lobbyists that had kind of helped with this. Cordia Energy, I don't know if you know what Cordia is, but they run the large district energy plant down in Minneapolis. That we just did a study for them with the old Wells Fargo building about converting that. They're going to put up 2 new resi towers there. We want to do a central energy plant that can feed not just those 2 buildings, but other buildings with geothermal. And we want to do open loop reinjection, but right now it's currently not allowed in the state. And so we think that that's through and on the governor's desk, ready to be signed. So that could open up larger systems that can be utilizing in urban areas like downtown Minneapolis and St. Paul, where normal geothermal just isn't, an option because there's no space. And by the way, the Prairie Island in Red Wing is going to be the largest open loop system in North America that we're designing right now. That is a pump and reinjection system, and it's going to serve the entire casino and hotel there. Yes, John.
Hey, Brian, since you've been involved in the industry for a while, back in the early 80s, we had a real debate with the federal government because of the term geothermal. Geothermal were considered to be ground or high temperature ground source of energy. And
Yes.
it seems like the ground source heat pump people have kind of taken over the term geothermal in the
That's true.
legislation and regulations and so forth. Do you end up
Yeah.
using the term geothermal, or do you use ground source?
Well, that's a really great question, John. And our industry really has been, over the last 2 decades, just been terrible at terminology and everybody getting on the same page. We have, organizations call it geo exchange. We have organizations call it ground source heat pumps. We have other organizations calling it geothermal heat pumps. The key to all of it is that the word heat pump needs to be associated to the word geothermal or ground source or whatever, because we are not using direct use or producing electricity. And this is all shallow geothermal, where we're just using it as a thermal exchange with the ground. So yes, we've had this issue. There's a lot of states that have old state statutes that specifically only talk about geothermal direct use, and that created a lot of problems over the years. But most of them have been rectified ever since the federal government and the Department of Energy had come out and said geothermal heat pumps, and they've coined it as that. The industry kind of continued to go with that terminology. So that's what we use. Yeah.
Hey, Brian, can you also comment on the whole concept of reinjection and why it's a challenge?
Yeah, sure. So, obviously Minnesota, we have some of the best groundwater in the nation, if not the best. And so, obviously nobody wants to do anything that's going to hurt the groundwater or potentially, contaminate the groundwater. So in the past, and this actually stems way back from, the 80s, both downtown Minneapolis and St. Paul were on open loop systems, but they were a once through system. And so they would pump water out of the ground, run it through the heat pumps in the buildings, and then they would dump it in the river, down the storm sewer and in the river. And in the late 80s, the DNR and the Department of Health all said, okay, we're really pulling too much water out of the ground, enough. And they had to go in, and that's when district energy really took hold. And also boilers and cooling towers went in everywhere that district energy wasn't, to run these heat pumps. And they got rid of the open loop. And that kind of put the open loop as a technology that nobody wanted to use anymore. And even in residential, about the time the tax credit came out, I think early 2000s, 2005, the DNR came out and said nothing over 1 million gallons a year can be pumped out and dumped onto the surface out of the ground. And so even residentially, that's like a 4-ton heat pump. So even residentially, all the open loops that had been done for years had been now all closed loop systems. But there's a technology where, if done correctly and the water is good and it's readily available and there's enough, you can pump out of an aquifer, go through a heat exchanger, thermally exchange, but don't do anything to the water, and put it back into the same aquifer. And as long as it goes back to the same aquifer, you're just changing thermal energy. You don't do anything to that water, and it stays within that aquifer. And we've got a lot of hydrogeologists on our team, and this has been happening in a lot of different places in Ontario and out east, and it works very well. And it has to be the right scenario. It has to be the right, the chemistry and everything has to be right. But if it's right, which Minnesota has very shallow aquifers, has good water. Most of the shallow aquifers aren't drinking water. But there's abundance of water that we could utilize for this technology that could give us thermal energy, but we don't do anything to the ground itself. And so that's what they finally realized. Like, as long as you put it back the same aquifer that you got it, and you protect all the other ones around it, then we can do this. And so that's why they're now changing kind of their tune on open loops, because now they're looking at it from an open loop reinjection, not a surface discharge. Cannot put it on the ground. Yeah. So that's kind of what's happening, here in Minnesota. Colorado has passed similar legislation for thermal energy networks, pilot projects. Massachusetts has done the same thing. Obviously, that National Grid and Eversource are both doing pilot projects. New York State has passed a similar bill where they mandated all regulated utilities, including gas, to do pilot projects. So there's about 7 pilot projects going on right now. We're working with Orange and Rockland and Con Edison on a large one, currently starting design. We got through concept phase. up in a little town called Haverstraw, New York, right on the Hudson River. So there's a number of projects going on there, and so there's a lot of this is starting to really take shape, and a lot of states are seeing this and also passing similar legislation. So I think you're going to see those momentum continue to carry, especially a lot of the states, that have very aggressive goals when it comes to climate action, right? If you're down, I hate to say, but in the southern, states, they just don't have the same goals and climate action plans at this point, and so they're behind. And but if you look at the Midwest, if you look at the Northeast and the Northwest, they're all doing the same thing. So, Doug asked me just to talk a little bit about our goals, just as an organization. Obviously at Salas O'Brien, we really believe in this energy transition. We believe, we had a system for 100 years, a legacy system that got us to where we are today. These old legacy systems worked, but now it's time to really, up the game, think more, not just about heating and cooling buildings and getting everybody, heating and cooling, but now it's how to do it, efficiently. How do you do it environmentally, correctly, sustainably, no carbon, renewable. So these are all the things that we do every day. We look at recovering, repurposing, reducing, and that's just kind of our goal as an engineering firm outward to our clients and to everybody that we're engaged with as an organization. And so these are just the things that we live by, and it's across all business units. So with that, I'll just kind of give you a real quick, kind of example of one of the projects that I've been involved with. This is actually down in Florida. It's a developer that we've been working with. I don't know if you've ever heard of a project called Whisper Valley, but it's probably the most premier energy efficiency development in the country right now. It's a 100% renewable, no carbon. It's all solar, all geothermal. It's been being built out for over, close to a decade. They're all thermally connected with each other. And it's just outside of Austin, Texas. And this same company is doing this development in Florida. And so this is a multifamily project. So these are all apartment buildings. They're 4-story apartment buildings and a clubhouse. And so they came to us and they said, we want to kind of do the same thing. We want to do geothermal. We love geo. We want to do solar PV. We not only want to do it on the buildings, we're going to put up carports. We want to do as much solar as we can. And let's get this project to net zero, no carbon emissions on site and net zero energy if we can. So we looked at it and we thought, okay, great. First of all, if you know anything about Florida, Florida does not have great geology for closed loops. You hear a lot about sinkholes in Florida, right? So Florida has a lot of underground rivers, a lot of underground aquifers, a lot of potholes and voids. It's very fractured limestone. So what it is really good for is it's good for open loop reinjection, because you can pump a lot of water that's really close to the surface within the top 200 feet. It's not drinking water. And we can pump it right back in and it'll accept all that water just as you're taking it out. So you don't have any mounding or issues with the return well. So the initial concept was this: we'll put heat pumps in all of the apartments. We'll put a couple of energy centers in. We'll put in some wells and some reinjection wells, and we'll use geothermal to do all the heating and cooling. And then we're going to take waste heat off of the heat pumps and also heat the domestic hot water. And then we're also going to put solar PV on this site. And we're going to run all these electric devices, the heat pumps, the well pumps, all off of the solar PV. And let's make this another shining, star as far as the development. So this is kind of what we came up with as a design for the geothermal. And you can kind of see if my cursor works here. Let's see, where am I? Here I am. We have what's called an energy center up here, an energy center down here. We have some supply wells because the underwater hydraulic movement of the water goes from the southwest to the northeast. So we put all the supply wells on this side and put the return well over here. So the heat that was being put into the ground would be dumped and follow the direction of the underground flow and be dissipated before going and not getting recirculated back to the supply wells. And so there's two for redundancy, 2 supply wells, 1 reinjection well for each energy center. And then we thermally connect to each of the 3 buildings on this side and 3 buildings on this side to each energy center. So they can actually share energy. And also it just reduced the amount of, buildings we needed, where we were going to put stuff, and how many wells we needed. So that's kind of how that all worked out. And that's almost fully operational right now. They're just going through the commissioning. It's constructed and people are starting to lease the apartments. And then we also did the solar. So we went through and designed the entire solar array of the project. So we looked at all the sloped roofs that were really beneficial for solar PV. We looked at the carports. We did all the analysis. And after we did all that, we came up, obviously with our energy intensity. So this was the baseline. So if you just put in normal air conditioners and electric water heaters and lights and your plug loads and everything that goes into these apartments, you're roughly around 32 kBTU per square foot per year on a baseline on a new build. Okay, which isn't terrible, but it's not great. In Florida, it's mostly air conditioning, not a lot of heat. You've got obviously domestic hot water, but still relatively high. When we added geothermal to this project, because now you're talking about Florida and you don't have a lot of heat, it's all cooling, and the ground, is still relatively warm. Our ground temperature was 78 degrees. So, you only got a delta T between air and ground and throughout the summer months of maybe, 15 to 20 degrees. And that's where you gain your efficiency. So in Florida, your EUI and your efficiency doesn't dramatically decrease with geothermal, straight because of the temperature of the ground, the temperature of the air, and the fact that you just don't have a lot of heating hours. Okay. But we reduced it to 24, which is good. But then we look at the solar, and we looked at actually 3 different solar panels, but I'll just, just show you what the premium efficiency solar panel looked like. Now look at our EUI. We're down to almost 0. So we're almost net 0 from a total site perspective. You can see, depending on the time of the year, that when we're producing a lot of electricity versus when we're using a lot of electricity, that we're just about 100%, almost off the grid, if you will. Which is excellent for this development. So really did a nice job adding the solar in, and had enough roof space to really do a good job with the premium panels. Not quite as good with the medium, and then the base panels were, a little bit obviously worse than the premium panels. So then we looked at the annual energy. Again, here's the base case, here's the proposed geo, and then we start adding in all the solar. And obviously the premium solar was the best solar panel. So you can see dramatic increase with solar in Florida, which makes sense. A lot of sun, and then just, of course, a lot of cooling involved, right? Which then directly relates to carbon. I mean, virtually no carbon emissions, just a little bit, and that includes the grid carbon. This isn't just on site. This is total carbon all the way from the power plant. So this is a true representation, not just on site. And then, of course, we looked at OpEx, which is your operating costs for the client to operate the site. Solar makes a tremendous, business case. Geothermal even made a pretty good business case. And so, yeah, that was a really interesting project that's being built just as I showed it here, and can't wait to see the final results from what we modeled to, to the actual operation of the system. So with that, yeah, that's kind of my presentation. That's all I really had. And I don't know if there's any other questions from anybody.
Brian,
happy to answer anything. Yes.
can you share a little bit more about the Prairie Island project?
Sure. Yeah. So, obviously, the tribe there doesn't have to follow, rules. They're not regulated the same way. Obviously, they're a sovereign nation, so they don't have to follow the Department of Health. But even so, the Department of Health has still been involved with this project because they wanted to monitor it. They just wanted to be aware of it. They wanted to see how it's working. So, Prairie Island is right there on the river, Mississippi River, just north of Red Wing. And we started looking at, so what they came to us, they said, we want to do a geothermal system. We want to get our hotel and casino off of gas and boilers. and we want to go geothermal. What can we do? And initially we started looking at closed loop because they have a lot of land there. And then when we started doing our geology, desktop study, realizing that you're sitting on a massive shallow aquifer connected to the river, that's just a big gravel sand bed that really kind of cleans and filters the river water, but it changes and thermally connects with the river. And as the river changes, and we thought, let's do a study on an open loop and see how well this would work. So we went through and did a kind of a desktop study initially. Then we went out and actually the next phase, we did a pilot test bore program where we drilled some small boreholes. We did some pump testing. We did some injection testing. And it turned out that the water quality was fantastic. There was very little mounding, so we could pump as much water as we took out of this shallow aquifer. It's a non-drinking aquifer. Like I said, it's just basically river water. So we designed a system that's got 7 supply wells and 10 reinjection wells, and we're pumping 7,000 gallons a minute to a heat pump plant that is now going to serve the heating and cooling of the hotel and casino without any gas being burned, without any cooling towers and any evaporative water being burned off. And so they're in construction now, and yeah, really exciting project. That'll be the largest open loop reinjection system in North America. So really excited about that, pretty neat. Yeah, and so the Department of Health is clearly paying attention, and I think that might have been some of the information that was used to help this bill, make it through committee and up to the governor's desk.
And you said that's one of the biggest in the country?
Yes, for open loop reinjection, yes.
Oh, okay.
Mm-hmm.
I'm wondering, hello, I'm Chris. I'm
Hey, Chris.
wondering, with all of the incentives that are currently in place and how it's really facilitating the movement, if things change in November, could you be upended?
That's a great question. I was just at 2 conferences the last 2 weeks, and that question keeps coming up. And, talking with the folks at GeoExchange, which is our advocacy group and lobby group, and we've got lobbyists that work on behalf of our organization and our industry. They don't believe the way that things are written that it would be very easy for the next administration, if it happened to turn a different way, to change back what's been done. They were hoping to get a couple other real clarifications from Treasury on a couple of things that would have even cemented it further. But even without that, they feel that is really going to be difficult to reverse. And primarily, there's a lot of things that are also attached to that ITC that Republicans like. If it goes back to even a Republican-controlled Senate, and if they happen to get a trifecta, even that there's things in there in rural America about manufacturing and farming and different things that most people believe they're not going to be able to piecemeal things out because of the way it's written, which means they're going to have to leave the whole thing. So it's going to be really difficult to change it all. So that's what we believe. Obviously anything can happen, but we feel very strongly about that. We don't think it's going to get reversed. It's creating a ton of American jobs, which is huge for both. That's a bipartisan issue. I mean, everybody can agree on American jobs. All this technology, specifically geothermal, all the drilling that goes on, all the pipe that goes in the ground, the heat pumps that are made, they're all right here. Everything's built here, made here, installed here. So that's huge. That's really you can show the benefit of giving these tax credits to these type projects, because it really does trickle down to the job market. So we feel good about that. Now, there's a couple of things, though, I want to talk about specifically with the thermal energy networks and utilities. One of the issues with the ITC currently is the Treasury just ruled they are not going to allow safe harbor for third-party ownership of geothermal infrastructure and 2 different entities taking tax credit, meaning the utility goes and puts it in, and a homeowner then puts in the heat pump. Neither of them get the tax credit. The tax credit can only go to a geothermal system that has both the ground loop and the heat pump connected and on the same tax entity.
Say that
So
again?
all third-party ownership of infrastructure projects like geothermal infrastructure, if they don't own the entire system, they don't get to take the tax credit.
So nobody does.
Not in that scenario. So these pilot projects, if CenterPoint Energy goes and does a pilot project, if they don't own the heat pumps in the home, they do not get the tax credit for the entire system. In most regulated utilities, from what I'm learning, talking to all these folks, they don't want to own things in people's homes. They want to treat it just as if it were gas, electric, water. It stops at your property and you own it from there. So that's going to be a real problem with the tax credit. So we really have to, this next session, we're going to try again. There's been a large push. I did actually, I did a fly-in. We did some stumping. We had a letter. We had about 12 senators. We had about 20 congressmen, women on the letter that were in support of a safe harbor that said, you need to give this tax credit to third-party ownership. And Treasury came back and said, no.
Why not?
We have no idea. We just, it's an old rule from the 20s, actually, when it had something to do with smokestacks back in the 20s in factories that were trying to take tax credits. When somebody else would lease a smokestack to an industry, and it's a very, very old law. Now, solar was able to get a safe harbor. But the reason is because it's on somebody's roof and they say, well, you could take it off and resell it to somebody else. Well, that's not really the case, because who's going to buy a used solar panel, right? Nobody. So it's kind of a weird ruling, but right now Treasury is not inclined to pass the safe harbor. We need more support. I think we're starting to see the utility coalition come together and support that. I think you're going to see that as more pilot projects and more utilities do this. You're going to see more support from their lobby groups. You're going to see it from, obviously our geo industry. I think you'll see it from large companies like, the investor-owned district energy companies like the Cordias and the Enwaves and the Evergreens of the world that want to go out and do these as well and own these systems, but don't want to really own the building side. I think you're going to see a lot more push from those folks, and maybe we'll all come together and maybe we can get it done in the next session. But again, that's going to be after the election. So hopefully next year we can get it changed. And, the issue is the clock's ticking. This is a 10-year window. And a lot of these projects are, 3, 4, 5 years between design and installation. And you got to have it turned on by the time, this sunsets, unless they extend it. But right now, it was a 10-year deal. So we're already 3 years in. We got to get moving. We can't have things like this slowing us down, because the more people look at that and go, yeah, I'm not willing to take the risk, of not getting the tax credit, it just kills the projects.
Right.
And that's going to slow the momentum. So, we've got to get this through this next session. It's got to get done, or that's going to be a real problem for the large thermal energy network systems, I believe.
So Brian, not to belabor a point, I'm Catherine. Closed loop versus open loop. It seems to me like you'd always want to go with the closed loop, right? Because then you aren't. Why? Why would you go with the open versus closed? Yeah.
I'll just give you the real quick, highlights between the two. So closed loop is obviously the preferred method. Number one, it'll last well past the building's life, right? The plastic pipe does not break down on the ground. It's reliable. It's resilient. It doesn't, corrode. The problem with closed loops is that you don't impact the groundwater, but the problem with closed loops is you just can't put them in everywhere, especially in dense urban environments, because you don't have the space. It takes a lot of room to put all this pipe, right?
Prairie Island isn't dense urban. Why would you go to
right? But I'm saying, let's say we wanted to go into Minneapolis and we want to do a building. Yeah, we don't have enough room to do a closed loop. There's just not. So that's where the open loop comes in, because I can do 3 wells on an open loop that doesn't take up more than a few hundred square, feet from one another. And I can do 1,000 gallons a minute and 500 tons, and I can do a building. But I can't do that with closed loop, because I need an acre. I need much more space, because all those pipes that have to go in the ground 20 feet apart take up so much room. So that's where open loop, really, I think, is a better technology, is when you get into the inner city, dense and really high load types of buildings like high rises and office buildings. Now, that doesn't mean though, in those particular instances, we got to look at other thermal assets, right? We got to look at wastewater, sewage heat recovery. We got to look at, other, if there's power plants nearby, if there's other bodies of water like the river, if there's, there's lots of thermal assets. You have to be willing to look at all of the potentials around a site. Like if the project we're doing with Con Edison, we're going to study the sewer, we're going to study the river, we're going to do closed loop geothermal. So we're looking at all three of those for that project, and that we're probably going to incorporate all three of them into the design. And that's really how you make it cost effective and how you can do it in areas where you don't have all this room and all this space for your typical, like a college campus where you got a lot of green space, or a high school where you got soccer fields and baseball fields. You
Right,
just
but
don't have
Prairie
it.
Island has lots of space. That's why I was asking.
Oh, why we did it there? It was cost. It was just
Cost.
Yeah, it was cost. I mean, really, it would have taken probably, I think they initially said 3,000 boreholes closed loop to 17 wells. So you got, a well's $1 million a piece, but at 17 of them, you've got 17 million. A borehole at 3,000 boreholes at, $25,000 a piece or $20,000 a piece. I mean, you're millions of dollars difference.
Brian?
Cost. Yeah.
If you, maybe you can explain the difference between the two and the fact that you've got to have such a large heat transfer area to get rid of the heat with a closed loop system.
Yeah. If you don't mind, I could just pull up a quick PowerPoint here if I have time. Let me.
Gil's had his hand up for a while, so I want to give him a chance.
Yeah. Let's see here.
Yeah, I would just wanted to follow up on your just conversation now is how realistic is it to retrofit a residential building, a house, in say St. Paul with geothermal? Is it realistic at all, or is it just out of the question?
In somebody's home?
Yes.
Yeah, it's realistic. It's not easy, you look at the yards are tight. You've got a lot of mature trees. Nobody likes to cut down trees when you're talking about doing something like this, even though it's green. You still don't want to cut down mature trees if you can help it. That's, people don't like to see that, so, and then just, you look at the size of some of these drilling rigs, they're huge. They're massive trucks. So the drilling technology is changing though. We're getting smaller rigs. We're able to do angle drilling. This technology is changing because of the mass, adoption and the hype around this technology right now with the tax credit. It's driving in innovation, not only from products, but from technologies and installation. We're getting a lot of oil and gas people coming in. We're getting huge firms coming in, from those markets that are going, we have better technology that can do this faster, better, lower cost. They're finally looking at this going, yeah, our old way of doing things with oil and gas, that's going to be regulated out. We're not going to have a job in 20 years. We got to start transitioning. And so you're seeing this already starting to happen. Large company out of Toronto bought a oil and gas company called Harris Drilling out of Calgary. They got 80 rigs doing geothermal all over the country right now. So you're starting to see some of this. Let's see, is this?
Are there any examples in the Twin Cities where
No,
people
that's
have
not it.
retrofit geothermal?
Residentially?
Residential, yeah.
Oh yeah, sure. Yeah, back in my old job, we did a number of projects. I don't know them off the top of my head, but I remember in St. Paul over by St. Thomas, the rig was in the front yard and it covered the whole house. And it was basically property line to property line, but they did it, they did it. So let me just see if I can get
So
something.
Gil, I'm aware of at Minneapolis Institute of Art, there's a block of row houses, old, 5-story, and a friend who lives in the middle of these row houses did have geothermal put in about 20 years ago.
Okay, thanks.
Yeah, let's see if I don't, this really kind of helps, but so with a closed loop system, you've got multiple bores, and so it's because you're not actually pulling water from the ground, you're recirculating water down a pipe and then back up a pipe, and
Can we
and
see
so it's
your
a closed
screen?
loop. Oh,
Your
sorry.
screen, Brian.
You're not seeing it? New share. Here we go. Can you see that?
Yep.
No?
Yes.
Yeah,
Oh, yeah, okay. So with a closed loop system, it's, there's two pipes that go down the hole. There's a supply pipe, the water goes down, it exchanges energy, comes back up, and then it goes back into the building. Okay, and then there's multiple. These bores are generally around 20 foot apart, and they can be anywhere from 300 feet deep to 1,000 feet deep, roughly. But they're not actually moving any water underground, just thermal exchange. And so for every roughly 200 feet of bore is equated to 12,000 BTUs, or 1 ton of capacity. So if you were going to do, 500 tons, you need a lot of holes spaced 20 feet apart to meet that capacity, because the exchange rate is so slow with the earth and the plastic pipe that it just takes a lot of ground mass and a lot of holes in the ground to exchange that much energy. Okay. Now, if these were open loops, we're actually going to pump water from the aquifer up the well, in through a heat exchanger, and then back out and put it in a different well. Well, the capacity is all related on how much water I can pump. It isn't related to how much pipe I put in the ground. It's only related to how big this well is and how many GPM I can pump out of that aquifer. So I could do that same 500 tons with one well if I have enough water in the aquifer to pump out, pump through a heat exchanger, and then pump back in. So an open loop it used to be called open loop because it was open and then you would dump it on the ground. So that meant it was open. It's really not technically opened. It's still a sealed system, but you're taking it from the aquifer, you're bringing it up into the building and putting it back to the aquifer. Where the closed loop doesn't do anything with the aquifer, it merely exchanges heat through the pipe, through the grout, into the soil, and then back again. And it just recirculates the same fluid over and over again, and just temperature change. So it takes a whole lot more pipe in the ground to do that, which means it takes up more space, and you have to have a lot of green space, to do the same capacity. But open loop doesn't work well either. We're looking at a project at Luther College right now. The best aquifer for open loop is 1,200 feet in the ground. It's the Mount Simon. Well, to pump water up 1,200 feet from the surface to the surface and then back down 1,200 feet is a massive well, a huge pump, a lot of pump energy, and a tremendous cost. And they have all kinds of space. So why would you put an open loop in, that's going to be that high of a cost and have to go that deep when you could do shallow 500-600 foot boreholes and just put 1,000 of them in, and you'll probably be lower cost because you don't have to go as deep. Prairie Island, we're only 150 feet deep. That's it. But we have enough water at 150 feet to supply 7,000 gallons a minute to the building. So it's really about the geology and the hydrogeology, where you're working. But that's the difference between closed loop and open loop. Now, open loop also, the downside is there's a wellhead. At each of these wells, there's a pipe sticking out of the ground. And that pipe, because you have to access the pump that's down inside the well. If it ever fails, you have to be able to put a truck over top of it. You got to pull the pump, the well lid, you got to pull the pump out, repair it, replace it. There's maintenance because no water is pure. You've got minerals. You've got different things in the water. So as you pump it back in the ground, if there's any little bit of oxygen, it starts to foul. It'll start to precipitate out of the water and stick to metal. So the screen that's in the well, it'll start to clog it up. So you have to go through and do maintenance. You got to flush it. You got to, chlorinate it from time to time, depending on what the minerals are. So there's maintenance to the open loop. So it may be lower cost up front, but depending on the size and how many well pumps and, then you got these things sticking out of the ground. We looked at one right here in St. Paul for a small little apartment building that's being built, and they didn't have any room for closed loop. We could put an open loop on one corner and the reinjection on the other corner, and it would work. But they're like, well, what do we do with these wellheads? I'm like, plant a bush around it. I don't know. But, that's the downside, is that they're not underground. The closed loops, you don't see them. everything is buried. You never have to access it. We put them under buildings. We put them under parking lots. There's no maintenance. You don't ever see it again. As long as they did it right, there's never going to be a leak. You just, they're out of sight, out of mind. How'd I do?
John, did you get your question answered?
Oh, I had a different one, but
Okay.
he answered my earlier one. I mean, this might be not for this conversation, but I have a system. I have a solar system. My house I built 8 years ago on my property I grew up on in Linden Hills. And I had Gens Ryan come out and look at geothermal, and it's a small lot. And I'm up on the hill between Lake Bedamacuska and Lake Harriet. And they said, your property's pretty small. We could go deep. I think your first description there. And then they said, but if you got the solar option, which I eventually did, they said, in your neighborhood, we will also hit bedrock, and it'll cost us more to get through it.
Yeah.
So he said it would cost you 60,000, not 30. So
right. No, that's one of the issues with our formation here, especially in Minneapolis and St. Paul, with closed loop geothermal, and the way that the state regulation and code is that every time you go through a different aquifer, now you have to case off the upper aquifer. So generally with closed loop systems, you only drill to 250 feet, because at that you go through, I forget if it's the Jordan or whatever it is, and then you get to the next aquifer, we generally stop, because if you penetrate the next aquifer, now you got to put casing in the top aquifer, which drives the cost through the roof. And so closed loop in those locations to go deep doesn't make a lot of sense. So if you don't have the room to at least put 3 or 4 holes in, or 5 holes, and you got to try to drill deeper, the price of the bore goes really high per foot. And so that might have limiting factor. Yeah.
That might have helped answer Gil's question too. So I did the solar. It's going to pay itself off this year, year 8. I have SIP panel home, highly insulated. And so, but I have a strange question. So I have heat pumps too. I have 4 heat pumps in a small house, and they're commercial grade. They're from Canada. I still turn them off at about 20 degrees because I've got a small, highly efficient heater in the basement I put in after the fact, and it cost me $80 for 2 months to heat my house.
Right.
But I wanted to ask you, what's the difference between an electric heat pump like I have and the geothermal heat?
Yeah, I don't know if it's you breaking up or me.
Is it the way they won't? So just wondering, is there a difference between a regular current home electrical heat pump and a geothermal heat pump?
Yeah, that's a great question. Residentially, the air source heat pump technology has gotten much better. They have these cold climate heat pumps now that'll run down to about 0, even below 0. Now the efficiencies aren't great, obviously when you get down to that cold, because you can't really change physics. So the refrigerants that are being used, the components, the compressors are no different from a geothermal heat pump to an air source heat pump. So the energy source is the air versus the ground. When we design a geothermal system, we never really get below 30 degrees on our ground loop. Even in the middle of winter on the coldest week, you're pulling all that heat out of the ground. The fluid will get down to 30. The ground itself is 50. It's still moving heat, and it'll be able to sustain that kind of, heat transfer rate to keep it running. And you're not going to dip below 30, which means your efficiencies stay at 3 COP or above. Now, an air source heat pump, it sits outside. As soon as it gets 20, 15, 10, 0, that efficiency and capacity continue to drop. You're going to be below a 2 COP, closer, electric resistance is 1. And it's also harder on the equipment, but the bottom line is they'll still operate. They're just not as efficient.
They cost a lot more electrically.
They're going to cost more, right?
Go below 20. So
yeah, exactly.
What you're saying makes complete sense, but keep going with that. So it stays at about 30. And then what?
Yep. Yeah, so the ground doesn't ever, locally right around the pipe will start to cool off, but obviously the further away you get from that bore, the ground is 50 degrees, and it continues, as you change the temperature, continues to move heat into that bore field area and warms that fluid and keeps bringing it into the heat pump. So when we design Geo, we put enough pipe in the ground so it never gets below about 30 degrees at the worst case in the middle of winter.
That
Okay,
helps.
so that means we're always going to try to run around a 3 COP or more. With the new technology and some of the heat pumps, they're even a little higher than that. And not only that, the higher the efficiency, but also the higher the capacity. So with heat pumps, your capacity is also direct related to that temperature. So your air source heat pump, not only does it lose efficiency, but it loses capacity, which means then it has to run more.
Yeah.
And the more that it runs, the more you're going to spend. Where geothermal, it's still going to shut off. It's still going to, let the ground loop recuperate and then turn back on and cycle correctly. So you don't get into that, we call it a death spiral, because as efficiency and capacity degrade, it runs more, which then then everything keeps going down and down and down until it just bottoms out.
Well, thank you. That makes complete sense. Right.
Yeah.
Thank you. Yeah.
Yeah, no problem.
Well, hey
But
guys,
like I
we're
said-
gonna have to shut this off.
Yes.
We're coming up on the MRES board meeting. Brian, thank you for a fantastic presentation.
Thank
This
you.
was just super informative in every way. And
Yep,
Okay.
no problem. Happy to do it. Thank you very much for having me. Appreciate it, and have a good evening.
yes, take care.
Yep, take
Yeah.
care.